Good morning, friends. In my last video, I explained you some fundamental properties of the isomers, in which I explained you chain isomers and the position isomers. Today, in continuation, I will explain you functional group isomers, metamers, and the tautomers. In the case of the functional group isomers, what this indicate? This indicate function group. It means molecules having the same molecule formula but different function groups in the molecules. Listen, having same molecule formula but different function group in the molecules. It means in the molecule, functional group itself changes. That is known as the functional group isomers, and this phenomenon is known as the functional group isomerism. For example, if we take first example C2H6O. Now it may exist in the form of the dimethyl ether and the ethanol. In first case, functional group is ether, that is O, and in second case, functional group is R, that is OH. So the molecule having the same molecule formula, but the function group differs in the same molecule, that is known as the functional group isomerism. If we take the second example, C3H6O, then it may be right in the form of the CH3, CH2, CH2, that is aldehyde, and it may change itself to the keto group, that is CH3CO, CH3. So here, molecule formula is C3H6O, but it exists in two functional groups, that is aldehyde and the keto groups. In this case, aldehyde group is CHO, while in this case, keto group is CO. Now if we take example 3, that is carbonic acid and the esters, CH3CO, that is ethanoic acid, or this COH group may convert into the methyl format, that is the ester. So here COOR, that is ester, and here RCOH, that is the carbonic acid. So the point is that if they have the same molecule formula but the function group changes in the molecule itself, that is known as the function group isomerism. Now we take one more example, that is cyanides and the isocyanides. Cyanide, that is methyl cyanide, CH3Cl, double bond between the carbon and the nitrogen, and when it changes to CH3Lc, that is methyl isocyanide. So they are the examples of the function group isomerism, in which same molecule formula but different functional groups in the molecule, that is known as the functional group isomerism. Now the metamerism. See, in this case, if having the same molecule formula, listen, but different number of the carbon atoms are the different alkyl groups on both sides of the functional group. Again listen, metamerism, having same molecule formula but different carbon atoms are different alkyl groups on both sides of the functional groups. That is known as the metamerism. For example, C5H10O, sorry, it may form diethyl ketone, that is pent 3 on, or it forms the pentene 2 on, that is the methyl propyl ketone. And we take another example, C4H10O, it may form the diethyl ether or the methyl propyl ether. So in this case, both sides of the functional group having the different carbon atoms in first case and in second case, and in way, see the next example, here it is diethyl ether, now here on the ether both side, on one side methyl group and the other side is the propyl. So this is the metameres which have the same molecular formula but different carbon atoms are the different alkyl groups on both sides of the functional group. Now third is tautomers. That is a special type of the isomers. It's very important. Tautomers. Isomers differ in the arrangement of the atom. First point. Isomers differ in the arrangement of the atoms, but they exist in a dynamic equilibrium state. Again listen. Tautomers. Isomers differ in the arrangement of the atoms. First point. Second, but exist in dynamic equilibrium with each other. For example, we take example of the ethanol CH3CHO that may form the vinyl alcohol. So here ethanol and the vinyl alcohol, they exist in an equilibrium state. That is known as the tautomers. So this is about the functional group isomers, metamers and the tautomers. In my next video, I will explain you space isomers. If you like my videos, please share and subscribe. Thanks very much.